Hello, everyone, and welcome to the fifth and final session of our Tech Talk series with Confluent. Before we begin, I have a few quick announcements. This session is being recorded, and a link to the recording will be sent to everyone who registered. If you have any questions, please submit them using the Q&A feature in Zoom or by typing them into the chat box. We'll answer all questions at the end of the session. With that, let's jump right on in.
All right, hello, everybody. My name is Bondo. I'm a solutions engineer here at Confluent, and I'll be the presenter today talking through anomaly detection and fraud detection. So just for awareness and planning, expect this webinar to be roughly 20 minutes or so. And the agenda items are as followed. First, we'll kick things off talking about the different types of fraud the government is currently facing, some recent fraud reports in the news, talk about a few industry trends in terms of detecting fraud, and then talk about how Confluent can help in this capacity, and then wrap up with a couple of customer testimonials and then Q&A. So to start, 6 forms of fraud that the government is currently facing. These were found as kind of being the 6 most impactful. Starting in the top left, of course, identity theft, stealing someone's social security, someone's bank account number, and committing fraud that way. Below, kind of similar vein there, credit and payment fraud. You're able to steal someone's credit card information and be able to use that for illicit transactions. Impersonation scams are a newer one that may not be thought of as much, and they're becoming more and more prevalent. So in the scope of the government or the public sector, this could be a nefarious individual acting like an IRS agent to be able to get money from a citizen, or somebody from tech support trying to get into somebody's computer, but ultimately just enacting as somebody else within the government to be able to get information from a citizen. And then in the right column, we have internet and phone scams. Again, there's a more traditional get information via internet, email, phone. Grant fund is very specific to the government. It's a little bit of a 2-pronged issue here. So first, it's in terms of the application for the grant itself. In a situation where somebody, an entity or person applies for a grant, they could intentionally use the wrong information or incorrect information to be able to get these grant dollars. And then after the fact, an individual or entity could also be using these grant funds for reasons that they weren't originally or officially given these funds to be used for. Welfare and benefits fraud, similar to grant fraud, but more of just kind of an individual basis. Somebody is applying for some sort of government program, welfare and other benefit, doing so with incorrect information, or also potentially just using somebody else's identity. So these are 6 kind of major fraud types the government is currently facing. And then in terms of what's happening in the news, or just kind of what's happening out there in terms of recent fraud articles, I picked these intentionally just to show the different kind of scale of fraudulent attempts. So from the top option here is one individual, so a single defendant, was able to defraud the government over $1 million in SNAP and Medicaid benefits. So how this took place is this individual actually first committed identity theft. They were able to steal, get the exact number, but X amount of identities of others, and then apply for government benefits on their behalf unknowingly, and then went forth with these government benefits that were then given to these individuals, sell those in person at given grocery stores or different stores just within the community there. So you can see how one individual can still cause quite a mess here, $1 million, and also bring in all these other people that had their identity stolen and all these other people that purchased these benefits incorrectly or wrongly. Sort of the other end of the spectrum here, it's a massive healthcare fraud takedown that took place earlier this year. And you can see by the numbers on the left, just the scale of this. So in terms of intended fraud loss charged, almost $15 billion. So massive scale here. And then the middle section, you can see 324 defendants charged. So wide network of individuals and kind of this fraudulent network that was across the country. So see on the right here, that also depicts the different states that were involved in terms of states that were involved to crack down on the case, but then also individuals within those states that were committing these level of fraud. And this was healthcare related. These were like doctors, pharmacists. So kind of a crazy case here, in case you were not aware. And then at the bottom, this ties into the impersonation category that I called out earlier, but FBI is warning New Englanders to be aware of law enforcement and government impersonation scams. So nefarious individuals out there trying to contact citizens saying there's somebody from law enforcement or government to get money, information. Of course, when you hear something that you think is from the government, you obviously take it very seriously. So It's a tough form of fraud to crack down on, but it's very much becoming more and more prevalent. So some industry trends. This was a publication done by Deloitte Insights within the last couple of years talking about the advent of AI-assisted fraud, which again is kind of in tune with what I just mentioned about impersonation fraud and how it's actually done. So from a kind of dollar loss estimate here, you can see the lower end here was without any Gen or AI assisted fraud. And they were saying by the end of 2027, that would be in the neighborhood of 17 or $18 billion. But now with this additional layer of complexity of AI assisted fraud, see the other tangents that came about in 2023. So depending on if you're kind of going with the aggressive estimates or the conservative estimates, we'll just go for the upper bound for this example. That's in the neighborhood of $37, $38 billion. So double based on what they originally anticipated without this AI assisted fraud. So obviously a huge issue in trying to figure out how to resolve this. So a couple other call outs from the article that are worth mentioning. So there's already an entire cottage industry on the dark web that sells scamming software from $20 to thousands of dollars. This democratization of nefarious software is making a number of current anti-fraud tools less effective. So two takeaways from there is just kind of I want to say it readily accessible because it is on the dark web, but in terms of just from a cost component, and the lower end being $20, I mean, that opens up to a lot of individuals being able to purchase this type of software. And then also the software that's going to be combating this type of fraud or anti-fraud, it's calling out that these tools are becoming less and less effective. So obviously, big deal there as well. And then kind of reinforcing that thought, here's another excerpt from the publication. A US Treasury report found existing risk management frameworks may not be adequate to cover emerging AI technologies. So just again saying that the protocols that are in place might not be effective given the change in kind of the fraud landscape. So how these are changing or how these fraud attempts are changing, or rather how the fraud detection landscape is changing, break it up into kind of two buckets here conceptually. In the top, you have the traditional rule-based approach to fraud detection. So in the order of events here, it's being illustrated as you have a scammer, an individual, it's doing some sort of fraudulent behavior, some sort of illicit transaction, and that's going to a rules kind of engine to determine if kind of the data that's associated with that fraudulent attempt, does it kind of qualify with one of these rules that have been created to be able to kind of categorize it as potentially fraud or not. So that's the traditional approach, one that's continually going to be used, not to say that it's legacy by any means, but there is also now a machine learning based approach kind of combat these more sophisticated fraudulent attempts. So order events here are shown as kind of the user executing a transaction, just like the above example. But instead of going to this rules engine, where it's kind of pre-developed rules based on historical understanding of fraudulent attempts, it goes to an AI engine that has also been trained on similar types of data to then be able to find these kind of more ingrained or tough to determine patterns within the data to hopefully lead to more kind of exposure to these sophisticated fraudulent attempts. So these are the two conceptual kind of ways to depict fraud at the moment. And yeah, this is kind of goes into a little bit further. Covered most of these points, I guess, call out here, but with a rule-based approach, high false positives, which is of course better that way than kind of the opposite, but that then takes more kind of human hours to then go in and do a manual investigation about that scenario. Or an ML-based approach, the hope is that it's going to be more adapted to new tactics. You know, as more data is being kind of flooded into that ML model that's specifically built for the situation, it's going to be able to find these relationships that are more difficult for humans to kind of create or detect that would then be kind of pushed into a rule-based model. So it's kind of the advantages of the ML-based approach. And then one big takeaway here, this is Gartner's layered fraud prevention approach. Main thing to take away from this is that it's not to say it's one or the other, like a rule-based approach or ML-based approach. It's using these in tandem plus other additive measures to be able to detect fraud. But you're not just going to rely on one system, one technology, or one kind of method. The idea is that you kind of have these various different layers to hopefully be able to catch more and more fraudulent attempts. All right, so 3 techniques to help detect fraud using Confluent. So bucketed these out, 3 different methods. The first one, which I think is applicable to people within all kind of elements of the public sector, streaming operational data to the data warehouse. So The assumption is that you're going to be doing some level of analysis for fraud detection or anomaly detection within the data warehouse. So whether you have an existing algorithm within the data warehouse to detect fraud, or you're leveraging an ML model to be able to detect fraud that way, it's going to be taking place downstream. And Confluent is great at being able to get the data as it takes place upstream, as somebody submits an application for a government program or as a transaction goes through, to be able to propagate that into the data warehouse. So whatever layer of analysis that needs to take place can happen in kind of an instantaneous fashion. And the two other options are going to currently be bound to Confluent Cloud as it exists now. So one thing just to keep in mind, but they're related to Flink. If you're not familiar with Flink, cover it here in a couple of slides. But within Flink, it has built-in ML functions. So straight out of the box, you can take advantage of these ML functions to be able to do some way of anomaly detection. There's also Flink AI model inference. So you can call an existing remote model to be able to run an analysis on a record, a transaction, an application, so it can give it some kind of risk scoring and associate that to whatever that given record would be. So those are three different techniques that Confluent can help with fraud detection or anomaly detection. And I'll get into them each with a little bit greater level of detail. So in case you're not familiar with Confluent, Confluent in itself is a platform for data integration and data streaming. There's a lot to unpack there, but just from a high level, one thing about Confluent is it's kind of the opposite approach of batch processing or more traditional kind of integration methods. So instead of having data that's going to be pushed between systems, once a day or once every hour, which ultimately leads to systems downstream with just kind of out of time data. They just have the old state of the data. Confluent instead pushes data or pushes chain records as they take place into the downstream systems that are necessary to read them. So you have more of a consistency between these systems. You have more up-to-date systems. That's what Confluent is going to be able to help you to achieve. There's also a level of processing the data as it moves through Confluent. Just alluded to Flink, which is a stream processing engine. So that's kind of within this kind of category here. You're doing some sort of change within the data. You're not just moving it between systems. You could be joining it to another data set. You could be enriching the data in some way. You could be doing some sort of aggregation to be able to group data and be able to then push that to like a materialized view to have some sort of understanding at a high level. This is what Flink is able to help you achieve. So that's in a nutshell, just in case you're not a current Confluent customer, you're not currently thinking as much about Confluent. So just to get into Flink a little bit further too, just in case you're not familiar, because two of those aspects are going to be around Flink for fraud detection. So Flink, as I just mentioned with processing, it's doing some sort of change on the data as it goes through kind of your data integration pipeline. So some advantages of Flink as a stream processing engine. This is mainly specific to Confluent Cloud, but you benefit from scalability and performance. Confluent Cloud runs Flink in a serverless fashion. So say you only are running, a few Flink jobs at a given point in time, and for whatever reason, those Flink jobs spin down and those statements are no longer needed for a period of time. Flink scales to zero. So the underlying infrastructure is no longer going to be allocated to your specific job. So you're not going to incur costs that are kind of unnecessary for you at that given point in time. Conversely, on the other side, if you're going to be running a lot of Flink jobs all of a sudden, and it's a distributed system in nature, behind the scenes, Flink is going to spin up additional task managers to be able to handle the additional Flink jobs that are taking place. So really benefit from scalability and performance there. Fault tolerance, Flink has some mechanisms in place to be able to handle if a Flink job would fail. It has this kind of intricate checkpointing mechanism. So basically state is retained and is durable on disk. So in a situation where the Flink job fails, it's a little bit more efficient in bringing the Flink job back online with the state that was kind of a part of that Flink process in the past. And then last aspect here is language flexibility. You can create and develop these Flink jobs with Java, Python, or SQL, so you're not just bound to one language. In terms of just Flink in the industry, it's widely used. This graph on the right shows kind of a mirror between Kafka and Flink utilization. So Kafka, of course, heavily utilized within the data integration, data engineering space. Flink, it's kind of on the same trajectory now. Just kind of know that it's widely adopted. It's by no means like a niche technology or anything. All right, so to the first point here, those are just kind of slides, just in case you're not familiar with Confluent or Flink, just to kind of have a basis of understanding here. So streaming operational data to a data warehouse. So on the left, seeing the operational state, these are like your user-facing applications. These are where somebody would submit an application to be able to get a grant, to be able to get some sort of government benefits, or yeah, like I mentioned, a transaction takes place. Confluent is great at being able to propagate those changes to other systems. And that other system can also be the analytical estate. And why that's relevant is because the analytical estate is probably where we're going to be doing that processing to detect fraud anyway. And now with the advent of ML, more than likely you're going to be running that ML model within your data warehouse as well. So Confluent is great at being able to propagate those changes to the data warehouse in real time. This slide depicts data warehouse or Databricks. We have a great partnership with them, but it's not just limited to Databricks. We have first-party integrations with other cloud data warehouses and other kind of legacy on-prem data warehouses as well. One other call out here I want to mention is that, we're talking about Flink and processing. You don't just want to think about, okay, Confluent's going to move my data to Databricks. It can also do some level of transformation there, right? Like you can add some context around the data. If you need to join it to different data sets, if you need to curate or change that data, you can do that prior to getting it into Databricks as well. All right, so the second two options here are around Flink. So there's built-in ML functions and AI model inference. So starting with the ML function. So I have two here called out. It's not limited to just these two, but I thought these would be most relevant for now. Pattern matching is the first one up, and this is going to be in line with kind of the rule-based approach that I was talking about earlier. So you define the pattern that you want to then have this data be, or this kind of record be filtered out by if it adheres to this pattern. So for this example, see the pattern is defined as, in the first transaction, if it's over $10,000, and if the second transaction is also over $10,000, to then basically classify this transaction or this record as being potentially fraudulent. So super basic example, you can add very complex logic in here, whatever kind of fits your use case. Anomaly detection takes things a little bit further. It is going to read and kind of analyze past transactions based on certain groupings of messages. And then based on kind of that historical data, it determines where an anomaly would lie there. So it takes things a little bit further beyond pattern matching. But yeah, these are both two functions that are out of the box within Flink. And then final option here, the third is around AI model inference. So in a nutshell, what this does is within Flink, you can call an AI model. It can be a foundational model like the one shown here in the graphic, or it could be one that your agency is currently working on and hosting themselves. So when a transaction comes through or an application or some sort of record comes through, and you want to have basically the model be able to determine if this has some level of risk or some level of fraud around it. Essentially what it does, so you define the query or the ML inference, you're calling out the model you're using. There would have been a step before where it's basically just like referencing the model you would use. And then the output of this is going to be the record itself for the transaction itself, and then like a fraud risk score. So it allows the model to then be able to determine what level of risk a given message would have here. So it is could be working in tandem with a rule-based engine, but this takes into account other data besides just what you have kind of the rules defined on. So those are three methods there, potentially be able to detect fraud and anomalies with Confluent. A couple of customer testimonials. We have Capital One on the left, obviously a huge banking customer. So they use this for fraud detection. Traditionally, they were doing a lot of their fraud detection using batch and nightly processing. Of course, from a time component, a little bit dated there. So they went ahead and built some additional kind of fraud detection methods using Confluent, taking into account a couple of these different dimensions: double swipe, duplicate charges, high tips, increased recurring charges. And they give kind of the ROI around this one, which is nice as well. So they improved their threat response and mitigated fraud costs with an average savings of $150 per year per customer. Instacart is a little bit more general here, but they're a customer of ours, and they saw us as being a great partner for fraud detection. Nate Cupp, the director of engineering, has a testimonial here around that. All right, perfect. So I appreciate your attention, and now I think we can answer any questions that are out there.
Thank you. I do see some questions in the box. The first question is, how does Confluent integrate with ML models for real-time anomaly detection and fraud scoring?
Yeah, sure thing. So probably the main pattern is going to be, I covered a little bit ago, around using Flink for AI model inference. So just to get into that a little bit more detail, like a message or a record would come into Kafka that would then be read by Flink. And then Flink would call out to a model that could be externally hosted in the cloud or on premise. And then the model would then associate a risk score or classify that record with some additional level of detail.
Thank you. I do have another question in the box. What kind of fraud signals can be detected through event streams that might be missed with batch analytics?
Yeah, so I would say it's less about the additional fraud signals that could be picked up with streaming versus batch, and more so it's just the element of time that's of most significance there. So the situation I was talking about with the past banking customer, like traditionally some level of their fraud detection or anomaly detection was done in nightly batch jobs. So what they missed out on there was the time component to be able to minimize their time to insight and realize that some fraud pattern could be taking place until later in the day when that analysis was run. A situation where if you're doing this through Confluent, kind of the incremental analysis taking place as the records or events occurs. So kind of time to insight there is kind of much more slimmed down there. So that's kind of the main advantage.
Thank you for that answer. At
Yeah,
this
no
time, I
problem.
do not see any other questions in the chat box. So we're going to move on.
All right, sounds good.
Mhm.
All right, so yeah, I appreciate your attention. Thank you, everybody.
Thank you all for joining our session today. We're thrilled you started the journey with us. To ensure you didn't miss a thing, we've compiled all the episodes into one easy access place. Head over to YouTube channel to watch the completed series. Thank you and have a great day.